Use DeMoirve's theorem to expand cos4θ and sin4θ in terms of powers of cosines and sines of theta. Hence obtain an expression for tan4θ in terms of tan θ. Use the results in 2 above to solve the equation 3 raised to power 4 plus 40 minus 60 squared minus 40 plus 1 is equals to 0. Now, using this Moirve's theorem to expand trigonometric functions in terms of powers of sines and cosines is very simple. So, if we have cos n theta plus j sin n theta to be equals to cos theta plus j sin theta all raised to power n, then it means when n is 4, we will have cos4θ plus j sin4θ to be equals to cos theta plus j sin theta all raised to power 4, isn't it? Now, having done that, it means what we are looking for is what is on the left-hand side of the equation, isn't it? Then is what we expand. So, we expand the right-hand side of the equation using binomial expansion. We use binomial expansion, when the power is 4, it means we have 5 terms, isn't it? When the power is 4, we have 5 terms. So let us have 5 terms. That is the first, plus the second, plus the third, plus the fourth, plus the fifth, or the last term. Then you start putting, the first term in this binomial expansion is cos theta, isn't it? So you put cos theta in the first bracket, cos theta in the first bracket. Then the second term in this expansion is positive j sin theta, which is just j sin theta. So you put j sin theta in the second bracket, j sin theta in the second bracket, j sin theta, j sin theta. Then you put the powers. One power is ascending, one power is descending, isn't it? So if the power of cos theta is ascending, then you start with cos raised to power 4, power 3, power 2, power 1, power 0. The other one descends, isn't it? So this one is raised to power, the first one is raised to power 0, power 1, power 2, power 3, power 4. Then you put the coefficients. When the power is 4, what are the coefficients? The first coefficient is 4 combination 0, you get 1. The second coefficient is 4 combination 1, you get 4. The third coefficient, 4 combination 2, you get 4 combination 2, you get 6. Then the next one, 4 combination 3, you get 4. Then 4 combination 4, you get 1. So you placed all the coefficients and powers. So the next thing is to simplify, isn't it? The next step is to simplify binomial expansion. So anything raised to power 0 is 1. Anything raised to power 0 is 1. Now what do we remain with? Here we remain with, on the right hand side of the equation we have cos4θ plus j sin4θ is equals to what? Now simplify this. The first term here we have cos raised to power 4θ. Because cos theta, if you raise the whole of it to power 4, it is written in short as cos raised to power 4θ, isn't it? Then you move with the second one. J raised to power 1 is just j, isn't it? So j times 4, that is positive 4j. Then cos theta is raised to power 3, that is cos raised to power 3 theta. Sin theta is raised to power 1, that is sin theta. You've expanded that, isn't it? You've simplified that. You move to the third term. J raised to power 2. J raised to power 2 is negative j, isn't it? It's negative 1, isn't it? So negative 1 times 6, you get negative 6. Negative 6. Then cos theta is raised to power 2, meaning you get cos squared theta. Sin theta is raised to power 2, you get sin squared theta. Are you seeing that? Are we together? You are done with the third term. Go to the fourth term. J raised to power 3. What is j raised to power 3? J raised to power 3 is negative j, isn't it? Because it is j times j squared. J squared is negative 1. So it is negative 1 times j, which is negative j. Is it? So you go there, negative j times 4, you get negative 4. 4j. Then cos theta is raised to power 1, that's just cos theta. Sin theta is raised to power 3, which is sin raised to power 3 theta. You're done with that term, isn't it? You go to the last term. J is raised to power 4. J raised to power 4 is positive 1, isn't it? Because it's like j squared times j squared, negative 1 times negative 1, isn't it? Which is positive 1. Then you remain with sin theta raised to power 4 is what? Sin raised to power 4 theta, in short. You are done. Now, the next step. The next step is to collect the real terms on their own and the imaginary terms on their own. So collect the real terms on their own and the imaginary terms on their own. So start cos4 theta. So cos4 theta is the real term on the left hand side of the equation, meaning it must be equals to the real terms on the right hand side of the equation, isn't it? A real term is a term without j, isn't it? So cos4 theta is equals to the first term without j on the right hand side of the equation is cos raised to power is what? Cos raised to power 4. Cos raised to power 4 theta. Then the next real term on that side of the equation is the third term, that is negative 6 cos squared theta sin squared theta. Then the next real term on the other side is positive sin raised to power 4 theta. So real term is equals to real term, meaning you've expressed cos4 theta in terms of powers of cosines and sines of theta. Are you seeing that? We are done with cos4 theta. Then you move to the next one, j sin 4 theta. So j sin 4 theta is the imaginary part. So when we have j sin 4 theta is equals to terms with j. So the first term with j is 4j cos 3 theta sin theta. The next term with j is negative 4j cos theta sin raised to power 3 theta. So you can see j is common all through, so it means j cancels out all through, isn't it? Are we together? So when j cancels out all through, you remain with sin 4 theta is equals to 4 cos cube theta sin theta minus 4 cos theta sin cube theta. So you've expressed both cos4 theta and sin 4 theta in terms of powers of cosines and sines of theta using DeMoirve's theorem. So you've answered the first part of that question. Are we together? Let us move to the second part of the question. The second part of the question, we've been told to use these values to obtain an expression of tan4 theta in terms of tan theta. Are you seeing that? We now want to obtain an expression of tan4 theta in terms of tan theta. This is like a case of proving a trigonometric identity, isn't it? So you now start, what is tan4 theta? Because we want to express tan4 theta in terms of tan theta using these two expressions we found, isn't it? Are you clear? Now tan4 theta, we know tan is sin over cos, so it means tan4 theta is sin 4 theta over cos 4 theta, isn't it? Isn't it? So where there is sin 4 theta, we put the value of sin 4 theta, which we found is 4 cos cube theta sin theta minus 4 cos theta sin cube theta. That is what we found to be sin 4 theta, isn't it? Then you go in the denominator, you leave a small space there where you will be doing the division. Then in the denominator we have cos 4 theta, substitute the value of cos 4 theta, which we found to be cos raised to power 4 theta minus 6 cos squared theta sin squared theta plus sin raised to power 4 theta. Having done that, we've now expressed tan 4 theta in terms of the powers of cosines and sines of theta, but they want it in terms of tan theta, isn't it? So it means for you to get tan theta, tan is sin over cos, it's sin theta over cos theta, isn't it? So it means we must divide everything by cos theta for us to get tan theta, isn't it? So when you are dividing everything with cos theta to get tan theta, you must divide with the highest power of cos theta in that problem, isn't it? So if you look in this problem, the highest power of cos theta is 4. Are you seeing that? So it means we divide all through by cos raised to power 4 theta. Are we together? So you divide both numerator and denominator by cos raised to power 4 theta. Cos raised to power, you divide all through by cos raised to power 4 theta. So having divided all through by cos raised to power 4 theta, the next step is to simplify, isn't it? I start with the numerator, divide all through with cos raised to power 4 theta, start simplifying the numerator. So the numerator we have cos raised to power 3 theta will cancel out with cos raised to power 3 theta in the numerator, meaning we only remain with one cos theta in the numerator, isn't it? So it is now we have there sin theta over cos theta. So the first term in the numerator there is 4 sin theta over cos theta, which is tan theta. So the first term in the numerator is 4 tan theta, because cos raised to power 3 theta will cancel with cos raised to power 3 theta in the numerator. So you only remain with one cos theta in the numerator, isn't it? So we have sin theta over cos theta, which is tan. So that is now 4 tan theta. You are done with that first term. Go to the second term in the numerator, it is minus 4. Then 1 cos theta in the numerator cancels out with 1 cos theta in the numerator. So we remain with cos raised to power 3 theta in the numerator, isn't it? So it means here we now have sin raised to power 3 theta over cos raised to power 3 theta, which is tan raised to power 3, isn't it? Are we together? You are done with the numerator, you go to the denominator. Cos raised to power 4 theta over cos raised to power 4 theta is 1. They cancel out, isn't it? Are we together? Then minus cos raised to power 2 theta cancels out with cos raised to power 2 theta in the numerator, meaning in the numerator you will only remain with cos raised to power 2 theta, isn't it? So there we have sin square theta over cos square theta, isn't it? Which is tan square theta. So there we are going to have minus 6 tan square theta. Are we together? Then you move to the last one, sin raised to power 4 theta over cos raised to power 4 theta is what? Tan raised to power 4 theta. So we have plus tan raised to power 4 theta. So remember, this was tan 4 theta. So you prove that you've expressed tan 4 theta in terms of tan theta using the expansion of cos 4 theta and sin 4 theta. So that is why they will ask that question in a different way. There are other means they can ask that question. They will tell you to prove the trigonometric identity that tan 4 theta is equals to 4 tan theta minus 4 tan cube theta over 1 minus 6 tan square theta plus tan raised to power 4 theta using DeMoirve's theorem, isn't it? They will tell you to use DeMoirve's theorem to prove this trigonometric identity. Meaning you have to expand cos 4 theta and sin 4 theta in terms of powers of cosines and sines of theta. Then after that, you use the relationship that tan 4 theta is sin 4 theta over cos 4 theta, isn't it? Then you simplify by changing everything to tan. Then you would have proved that trigonometric identity using DeMoirve's. So I see how to prove a trigonometric identity using DeMoirve's theorem. Okay? Are we together there? Good. Then now in Roman number 3, so use the results in 4 above to solve the equation t raised to power 4 plus 4t cubed minus 6t squared minus 4t plus 1. It is tan theta which is raised to power 4, it is tan theta which is raised to power 2, it is tan theta which is raised to power 3. So it means this t is tan theta. Are you seeing that? So you say let t to be tan theta. Are we together? You let t to be. So if t is tan theta, what will you have here? So on the left hand side of the equation where we have 4 tan theta minus 4 tan cube theta all over 1 minus 6 tan square theta plus tan raised to power 4 theta will be what? Where there is tan theta you put t, isn't it? Are we together? So it will be 4t minus 4t cubed over 1 minus 6t squared plus t raised to power 4. So if you look at that equation, you can see t raised to power 4 and minus 6t squared and positive 1 obeys what is in the denominator, isn't it? Are we together? And what is in the numerator, which is 40, the sign has changed, and negative 40 cubed, the sign has changed to positive 40 cubed, isn't it? Meaning that problem is equated to 1. Meaning this problem is equated to, if it is equated to 1, meaning you multiply what is in the numerator on both sides of the equation, isn't it? To simplify. So if you multiply both sides of the equation with what is in the numerator here, we'll get 40 minus 40 cubed is equals to what? Is equals to 1 minus 60 squared plus t raised to power 4. Then from here, if you simplify, you take everything on one side of the equation, you will now get the equation which is here, isn't it? If you take everything on one side of the equation, we'll get t raised to power 4 plus 40 cubed minus 60 squared minus 40 plus 1 is equals to 0. Because you can see positive 40 going on the other side of the equation, you get negative 40, isn't it? Minus 40 cubed going on the other side of the equation, you get positive 40 cubed. Meaning this equation only exists if and only if tan4θ is equals to what? The equation only exists if and only if tan4θ is equals to 1, isn't it? Are you seeing that? So it means for us to solve this equation, tan4θ is equals to 1. So this equation exists if and only if tan4θ is equals to 1. So what is theta? So theta means here we have 4θ is the tan inverse of 1. 4θ is the tan inverse of. So remember, tan inverse of 1 is pi over 45 degrees, isn't it? Tan inverse of 1 is pi over, which is 45 degrees, isn't it? So that is 45 degrees. So we have 4θ is equals to pi over 4. So what is theta? You divide both sides by 4, you get theta is pi over 16. After finding theta, you look for t, because t is equals to tan theta, isn't it? Yes. So t is tan 11.25 degrees, which is 0.19889, isn't it? And you are done, isn't it? Yeah. Good. Next example. What is other remarks? No.